Okay, so we're going to jump into it. Right now, you guys should be pretty familiar with this idea of bodies in your tree over here. When we're looking to use joints, and when we're looking to create an assembly, which are like kind of the same concept, is that we're going to start introducing the idea of components, which we probably have gone over before. So in terms of hierarchy within Fusion, we have sketches, which will bump, like as soon as we like create geometry from them, we'll create a body. And then in terms of like higher organization, all bodies can be organized into components, and then components can be organized into assemblies, and then assemblies can be parts of other assemblies, thereby making them sub-assemblies. So that's kind of like the hierarchy of all the units that we're looking at. And to get an idea of like what that looks like, if I select this body here, like as my first example, if I go down here and create component from body, what that's going to do is it's going to make a marker in my timeline, and it's going to move that body from here into its own component here. And if I collapse my tree, you can start to see how that organizational system starts to make sense. So this whole file is an assembly, and then within this assembly, I have like my own native body and then separate components within here. Because we're looking to create joints between all of these pieces here, we want to create all of these as components. And furthermore, like if I wanted to expand this, like let's say, I'll take this as like an example file. If I open this up, this is like a component in itself. I can choose to go over here. I did that backwards. And insert this, and it's going to add this as its own component. So it's like essentially just like all these terms are a hierarchical system of describing like what pieces of geometry belong where and like what they're classified as. And why that matters is because as soon as I start going to create joints under the assemble tool here, so if I have only bodies within my file here, I won't be able to create joints. I think it throws you an error even saying there's no geometry for you to create joints between. In order to create joints, you need components. So that's why I've taken all the bodies that I've sketched out here and just converted them to components over here. I recommend labeling these, like especially like a component is like in itself like pretty useful as far as like organizing geometry. Like if I have, I'm gonna scoot this back a bit. If I right click a body in here, it gives me all these options. Like I can save it out as an STL, I can copy and move it around. But as soon as I create a component, it gives me some extra options here where I can create additional bodies and components within this component, and I can also like save a copy out, like where it'll like create a whole new file within my my file explorer in Fusion, so that I can like make new stuff off of it if I really wanted to. So components are pretty useful to work with, but I'm gonna go back on track to like actually creating an assembly and a joint. So now that we have all components, we're like more or less set up. Let's see. As far as like creating motion and like our joints, kind of a key component, like right now, let me rewind actually, because this is another difference between a body and a component. If I have bodies like floating around in space here that are organized in our like primary assembly, I can't like click and drag this. It just like won't let me. But as soon as I start creating components, what we're doing is we're telling Fusion that like because these are their own components, they have a certain freedom within our space. So if I click on this component here, it's going to let me start moving that around, which can be incredibly dangerous. Like it does not leave a marker in my timeline. So if I'm relying on this component to be in a specific place and I start just like willy-nilly clicking and moving stuff around, this can cause you problems. On the flip side, because we have all components now and we're able to like move these around in our space, there's this position tool that automatically pops up, which will give you two options: capture position and revert. So if I hit capture position, what this will do is it'll essentially take like kind of a snapshot of like the layout of all my components, and it's going to add a marker within my timeline here and say this position is important. We like want to like stay in this position until we start moving stuff around. Conversely, the other option is revert. So if I move something around, I'm like, oh shit, like I didn't want that to be in that place. I'll press revert and it'll snap to its original position. Does that make sense? So this will start making more sense when we start creating joints and we start moving stuff around. We're gonna want like kind of a starting position for our animation. We're gonna twirl stuff around and like have to revert or capture our position to like use that as a reference point for when we want to start. But for now, let's say that like, for example, I want, let's see. So this track, like this piece right here, I essentially never want this to move. And I also need something, so let's say I have like this mechanical assembly, like theoretically I can hold this in my hand and I can still make it move, but ideally I want to have these components like fixed to this table so I can spin my wheel and have the slider move without having to like hold on to my components and like move them around. So what we're gonna do is we're gonna take this and ground it in space. What that'll do, let me slow down. I'm gonna right click this component, ground this in space. So as soon as I ground it, I won't be able to move this around. I can still reference it and I can still click on it, but what I'm telling Fusion when I hit ground is that I don't want this part to move in space. So I've seen a lot of students so far like go through their whole toy assembly, like create these really complicated joints with these really complicated mechanisms. They go to animate it and it just like explodes and like Fusion can't figure out. It's because they don't have a grounded component. So essentially what's happening is like one component, like they'll go to move or animate one component and just everything just starts flying around the place because there's no grounded reference for like how stuff moves. So just be aware that you usually want at least one grounded component. And it's somewhat situational, like depending on the joints that you have, you may have a couple other grounded components. Okay, now I think we can jump into joints. So under assemble here, we have like quite a bit of features. I'll go over a couple today and then a couple in some other demos later on through the module. Mostly what we'll be using is this joint tool right here. So let's see, I want to go over as-built joints as well. So, well, we'll start with as-built joints. So there's a difference between these two tools, and it's pretty situational on like when you want to use them. I'm going to click as-built joint here. So what as-built joints does is that, let's say I've sketched, like positionally, I've sketched these components more or less in the place that I want them. So like a good example is this slider right here. I want to use, like, the right time to use an as-built joint is something like this, where I've sketched and created my bodies and components already in relation to each other. So with an as-built joint, I can select this component, I can select this component, and it'll automatically calculate, oh, there's a joint between these two components, and allow me to like either make that rigid or the components move. So let me go back to the computer here and illustrate that. So if I select this component, I select this component, it's going to give me a motion type here. I don't want it to be rigid, I want it to be a slider. So we'll see. Oh, it might not. Okay, so it's asking for a reference right here. I'll go over what that means later on through the joint tool. But now that I have my sliding joint in there, I can click and move this. So as built joints, if you have components already built in a location that makes it conducive to like automatically calculate that joint, is when you want to use it. I use the joint tool, this one primarily, because, let's see, let's hit continue. I'm going to revert back to my original position. I use the joint tool because no matter what, like even if you can still use it even if bodies and components weren't sketched in relation to each other. So an example of that is this linkage here. Like if I wanted to create all as-built joints for this assembly, I could. I'd have to sketch this linkage like in place over this pin and then over the like other pin over there and then create the as-built joint. With just the joint tool, what I can do is I can go to my component here. I can select the point that I want to use and then create my joint without having to sketch and like make that relation as I'm building. Does that make sense? So two tools do pretty much the exact same thing, but it's like different situations on like when you would want to use them. So going into our actual joint tool, which is extremely powerful and useful, especially for like mechanisms like the one we're going to be doing in studio. The tree itself is pretty straightforward. We're going to have two components, and essentially what we need to do is pick two references for those components to match up with themselves. So I'm going to start with this linkage here. As I hover over geometry, you can start to see that it's highlighting some of these key points, like the middle of this circle, this like tangency mark on this edge. Like I can hover over here and it's going to prompt me to select one of these. Can you see this little like biscuit or puck or like whatever shape this is? So this is your orientation marker. So something like important to like keep in mind is that as I hover over these key points, my orientation marker is going to change. Like as I change over these faces and over these edges, like the orientation changes. What's always going to happen is that these discs, I'm going to select one on this component, I'm going to select one on the other component, and the discs always match up face to face. And there's a little smiley face, like kind of like open mouth smiley face. I don't know if you can see it, but it's like a half circle within there that they'll always meet up opposite of each other. Like you can always use the flip tool to like flip it over, but those discs always match up face to face. So I'm going to select, let's say, the top of this one and just be aware of like where my marker is. And then I'm going to select the top of this one. And I don't want this, I want this to be. So those orientation markers match up and then snap into place. From there, we have some alignment tools here to like determine the angle and like if we want to offset something, which I'll go over like kind of a use case scenario, which I've seen a lot later on in the demo. And then we have our motion types. So there's 7 different types, and they're fairly descriptive. So you should be able to pretty easily be able to figure out what they are. So like rigid just makes like a rigid joint between 2 points. They're just never going to move. Revolute, the 2 points will like move around each other. Cylindrical, planar, which I use pretty often, which is just like 2 points are going to be coincident on the same plane, but it will allow movement like across there. So you can do some really cool stuff with that. I find that the first 3 are pretty much what I use like 80% of the time, which is rigid, revolute, and slider. Those are kind of like the most common ones. For what we're doing, I want this to be revolute. So as my circle turns, I want this to revolve around my pin because it's going to stay positionally like aligned with my pin in my slot. So that's our first joint. As you can see, as I exit out of here, it leaves a little marker here that I can either find that within like my joints folder on the side here, or I can click on here and then like actually like manipulate that specific angle of what I want to be, or I can just click and drag this. Because my pin's not constrained in this slot, I'm not going to get any movement yet. All right. So we went over joints, as-built joints. Really quickly, I'm going to finish adding joints to this. So let's see. A pretty useful thing that I didn't go over in the other demos is that you don't need to do component to component. You can do component to sketch features. So a good example of that, and something that I do pretty often, is that for like this big wheel, I don't have a pin in the middle here, but I have my origin. Like I sketched that off of the origin. So I would use that as like my one of my references to say, oh, okay, like I can link to that and have it revolute around the origin. Similarly, like I've had some people do some pretty complex mechanisms in the past 2 modules where it's like all the components are like mated to themselves and they'll like move around but not quite the way they intended. So usually having like a underlying sketch where you can start to like constrain some more of that geometry to move it how you want is also really useful. So keep that in mind. Like it doesn't need to be component to component. You can like create a sketch or use the origin. I think you can also use like any of the other construction geometry, whether that's an axis or like you can create a point like on a piece of geometry using those construction tools in order to use that as a reference for a joint. So a lot of different ways to like mess around and like manipulate your way through that. Okay, let me finish adding joints here. So here's a good example where sometimes like it'll flip over. There's this little flip tool that'll let you get the correct orientation. So now this piece right here, I'm gonna hide my origin. So this should be relatively well constrained where it'll let me start moving this around and starting to get an idea of like how that moves. So pretty powerful to be able to just like quickly whip up like 3D geometry and mock up how stuff is gonna move. As far as like actually building your toy out, I would highly recommend like using a combination of both modeling and creating joints within Fusion and physically prototyping out. I've definitely gotten in some bad spots, like exclusively relying on like CAD to like kind of simulate like how stuff's gonna move in real life, not realizing there's a ton of other factors that go into like how stuff moves and how stuff's put together, that a prototype is sometimes way more valuable information than like a CAD model. So definitely just another tool in the toolbox, never like just one thing to use. So, okay, I'm down to my last joint right here. Essentially what I want to do is create a joint between here and here. So what I've seen a lot of people do so far is that either this pin is a different height than this pin, or somehow the faces aren't matched up. So what happens is that the top of this pin and the top of this linkage don't match up. So what'll happen is you'll try to create a joint and that's gonna create an error. And that's where our offset tools come in really handy. So actually to simulate this, what we'll do is I'm gonna take off like the top part here. So this is where Fusion will start to give you trouble with joints. So if I try and create a joint between these, it's gonna try and it's gonna throw me an error. Like if I exit out of here, it's gonna put my timeline like we tried, but we failed. I've seen this pretty often, and essentially what's happening is you're telling Fusion to take these 2 points and match them in the same space, but because I have all of these other constraints already set up, it has to essentially just like break its form and break its already previous constraints in order to make that position. So that's why you're gonna get an error. So the workaround around that is because we have our fancy, I'm gonna select this one, I'm gonna select this, I'm gonna still use it as a reference. Because we have our fancy offset tools here, essentially all I need to do is figure out the distance between that and then figure out the offset. So what I'm going to do is measure between this and measure between this. Copy this to click keyboard, and then we'll create our joint between here. Make sure I have the right one. I'm going to paste. So my value of what I just measured here, if I hit OK now, well, let me change this to regulate. If I hit OK now, our joint should be fine. If I click and drag, ooh, yeah. Fancy. So just something to keep in mind. Like if you have a lot of constraints and joints already in place and you go to do your last one and it's throwing you an error, usually there's just like a mismatch in that height or that distance where you start to have problems with like Fusion just not being able to figure out that position. Okay, let's see. As far as other tools I wanted to go over. Okay, so pretty useful one. Probably not something you want to use for this project, but something that I find is pretty handy for like simulating stuff is using enabling contact within an assembly. And this will probably be the last thing we go over today, so just hang in there. So what I'm going to do is I'm going to make this just a hair longer. Say 7 point. Oh, not 75. That's ridiculously long. Throw this 7.5. So we'll go over my assembly here. So if I move this all the way to its top position, you can start to see that I'm having some like overlap within the end of my slot here. So what some people do, and what this tool is useful for, is using contact sets or enabling contact. So if I hit this, right now what this is going to do is going to say, look at all my components and determine that I will never have any overlap and instead will have a collision. So I'm going to click this. It'll show up in my tree over here, and if I go to move this, it'll stop at the top of my slot and won't let me do a full rotation. So context can let you do some pretty cool stuff. Granted, like, sometimes it's pretty easy to break it. Like if I just start moving this around really fast, it's just not gonna like that, and it'll invert my joint. So just be careful. Like, it's not 100% useful, but I think that feature is pretty cool to be able to like manipulate stuff like that. So it's cool to do like joints and stuff, or gears and stuff, where it's just like all based on a collision. That'll let you like figure stuff out. Yeah, I think that's all I have for as far as like setting up an assembly with joints, and then creating stuff. Any questions?